Lesson 7, Methods of Sampling. Whenever a sample is drawn from the population, one must always have an understanding of the method used, because the quality and reliability of any statistical result is directly related to the quality and reliability of the sample. There are several different methods that statisticians utilize when collecting sample data. Numerous factors must be considered when deciding which method of sampling to apply, because not all methods of sampling are appropriate for any given situation. Even though there are several different methods of sampling to choose from, each of the methods that statisticians utilize to collect sample data incorporates some form of randomness into the process. That is, where each member of the population has an equal chance of being selected. Random sampling significantly reduces the likelihood of introducing some form of bias into the sampling process. It accomplishes this intention by facilitating the production of representative samples. For instance, if a population consists of 60% females and 40% males, when a member of this population is randomly selected, there is a 60% chance it will be female and a 40% chance it will be male. As a result, the randomly selected sample would become representative of the population. And the key to producing accurate and reliable results in statistics is the ability to obtain a representative sample. So let's begin the lesson with our most basic method of sampling. In simple random sampling, the sample is selected in such a way that every possible sample of the same sample size n has the same chance of being chosen. In this method, some random process, such as pulling names out of a hat or using a random number generator on a calculator, is used to select the subjects in the sample from all of the members in the population. To illustrate this method of sampling, we first need to identify the population of interest. Let's say that the population of interest consists of all the households within this neighborhood. Then, to conduct a simple random sample, we need to come up with some way to select households from this entire population such that each of the households have an equal chance of being selected. One way to accomplish this would be to obtain a list of all of the addresses of every household within this neighborhood. And then, using a random number generator on a calculator, we can randomly select a number from 1, representing the first house on that list, to n, representing the last house on that list. Whatever number is randomly generated, that household that occupies that position on the list would be a part of the sample. And then this process can be repeated over and over again to randomly select all the households in our sample. So let's say another household is selected, and another one, and another one. This process is continued over and over again until the appropriate sample size is achieved. In stratified random sampling, first the population is separated into distinct strata, or groups which share some common characteristic. Then a separate random sample is selected from each and every stratum. The sample size selected from each stratum could be the same, which is referred to as balanced, different, which is referred to as unbalanced, or proportional to the population for each stratum. That is, the bigger stratums make up a bigger proportion of the sample, and smaller stratums make up a smaller proportion of the sample. To illustrate this type of random sampling, we need to first identify our population of interest. So let's say all of the households contained in this neighborhood make up our population. Then the entire population needs to be divided into strata, or groups. A natural grouping of the households in this neighborhood would be by block. So each of the blocks would constitute our strata. Then, in stratified random sampling, a random sample is selected from each and every one of the strata. So starting with the first block, we would take a random sample of households within that first block. Then, in the second block, we would take a random sample of households within that block. And so on and so forth, taking random samples from each and every one of the different strata, or in this case, blocks within this neighborhood. In cluster random sampling, first the population is separated into distinct clusters, or groups which share some common characteristic. Then a random sample of clusters themselves is selected. Every member of each randomly selected cluster is included in the sample. As long as the characteristics defining the clusters is not related to the issue under investigation, cluster random sampling can provide a representative sample. To illustrate this form of sampling, we identify our population of interest of all the households within this neighborhood, and then this population is broken up into groups or clusters. A natural clustering of homes in this neighborhood is by block. Then, the clusters themselves are randomly selected. So among the 8 blocks in this neighborhood, we can just randomly select one of the blocks, let's say using a random number generator on a calculator. And if the number produced is, let's say, 3, then every single household contained in the 3rd block would be included in the sample. To get a bigger sample, we would just randomly select additional clusters. So using the random number generator on a calculator again, we could randomly select another block. Let's say block 7 is selected. If that's the case, then every single household in the 7th block is included in the sample. Notice the difference between cluster sampling and stratified sampling. Cluster sampling, entire clusters are included or excluded, whereas in stratified sampling, each and every one of the groups are included. In systematic sampling, first, some starting point within the population is selected at random. Then, sequentially, counting every mth member of the population, where m is some set number, is included in the sample. As long as the sequence of the members within the population is not related to the issue under investigation, systematic sampling can provide a representative sample. To illustrate this, we first identify our population of interest, let's say all of the households within this neighborhood. And then, using some random process, like a random number generator on a calculator, we could randomly select one of the households within this population. Let's say this one becomes our first household selected. Then, identifying our m multiple number to count, let's say for this example, m would equal 8, we would then count 8 households from this randomly starting point to select the next household. So 1, 2, 3, 4, 5, 6, 7, 8. So the 8th household will then become the second member of our sample. Then counting another 8, 1, 2, 3, 4, 5, 6, 7, 8, we get our next member of the population. And this process of systematically going through the entire population and selecting every 8th household as we go will produce our sample. This process is continued until we achieve the sample size that we desire or until we've gone through the entire population. As long as the order of these households has nothing to do with the type of problem we're investigating, then systematic sampling will produce a representative, unbiased sample. In multi-stage sampling, the subjects of the sample are obtained by applying some combination of the various methods of sampling in a step-by-step process. Each step or stage of the process utilizes one of the basic methods of sampling. For instance, the first stage of the process could utilize the cluster random sampling method, followed by a second stage of cluster random sampling. In the next stage, the stratified random sampling method could be applied, where the final stage of the process could use the systematic sampling method within each of the strata. Other methods of sampling do exist in the field of statistics, but in this course, we will primarily focus on the following methods: simple random sampling, stratified random sampling, cluster random sampling, systematic sampling, and multi-stage sampling.